Hi folks, so we're going to take a look at number 4 from the practice test. So here they're giving us this function f, and they're just giving us its graph, and they're asking us to draw the reciprocal of this function. Okay, so essentially what we do is we try to use some basic characteristics of the original function, and that should help us to draw a reasonably good graph of the reciprocal function. So the first thing I'm going to look for is the x-intercepts of the original function. So I see that there's an x-intercept there. So I know that when I take the reciprocal of 0, I get something that's undefined. And we saw that a 0 of the original function ends up producing a vertical asymptote in the reciprocal function. Okay? So I know I've got a vertical asymptote there. And while I'm on this in this area of the graph, I notice that the end behavior as x approaches negative infinity is that the y values are also approaching negative infinity. So we ask ourselves as well, what happens when I take the reciprocals of these very, very small negative numbers, and I realize that I'm going to get a number that's still negative, but that's really close to 0. So when y is equal to negative a billion, the reciprocal is negative 1 over a billion. So I know that the end behavior is going to be approaching 0. All right? So the other thing is that because these values are all negative, the reciprocals are also going to have to all be negative. So what we seem to have figured out is that the end behavior to the negative side is going to be approaching 0 from the bottom. And here, since there's a vertical asymptote and these y values have to all be negative, it must be going to negative infinity. But there's one more piece of information we can use, and that's the invariant points. We know that this function at this x value has a y value of negative 1, but what happens when I take the reciprocal of negative 1? I still get negative 1. So this point will also be on my reciprocal function. So now I think I have enough information to draw this portion of graph reasonably well. So I know this is going to be approaching 0 from the negative side as the end behavior, and I know that the values have to still stay negative, and so it's going to be approaching negative infinity to the left of that vertical asymptote. Okay, let's look to the right of the vertical asymptote. The y values are approaching 0, but this time from the positive side. Okay, again, these are all positive y values, so when they take their reciprocals, they have to remain positive. So this must mean that this is going to positive infinity. Another way to think about it is these numbers are approaching 0, and what happens when I take the reciprocal of a very, very small positive number? I get a very large positive number. So I know that I'm going to be going to positive infinity here. Okay, and let's take a ride all the way to the end of the function. I see that the end behavior is that the y values are approaching positive infinity. So when I take their reciprocals, well, take the reciprocal of a billion, I get 1 over a billion. So I know that my end behavior on this side will be approaching 0. Okay, so I'll just mark that off at the vertical asymptote and at the end behavior here. But we need to do a little bit of work in the middle to figure out what's going on. Okay, first I notice, hey, y equals 1. Wherever the original function is equal to 1, the reciprocal is going to be the same. So the reciprocal function 1 over f will also have a value of 1 at these points. Okay. And the other thing that we saw is that, well, wait a minute, here this function increases, comes to a maximum, and then starts to come down. If I take the reciprocal of these increasing y values, they're going to be decreasing instead. And we saw that where we have a local maximum in our original function, it's going to give us a local minimum in our reciprocal function. Okay, here we have a local minimum in our original function. It's going to give us a local maximum in our reciprocal function. Okay, so that's going to help me draw this curve. And here, well, this is just a little over 2. So if I take the reciprocal, I'll get something a little less than a half. So I'm not going to worry too much about being exact. So somewhere here, I know I'm going to have a local minimum. And somewhere here, I'm not even going to try to figure out, that's about 0.7. 1 divided by 0.7, I'm not going to bother. I know I'm going to have a local maximum somewhere around there. Okay, and so now that I have this information, I think I can draw it. So let me do the best that I can here. So here it's going to come to 1, and it's going to decrease, 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 decrease till I reach this minimum. Okay, then it's going to come back up, cross 1, reach this maximum. Okay, come back down, and now it's going to approach 0 at the end behavior. Okay, not the nicest looking thing in the world, but it does have the basic features of the graph. So just to repeat, you take your original function, look for the zeros, that's going to give you your vertical asymptotes. Look at the end behavior of the original function, that's going to help you find the end behavior of the reciprocal function. Look for points where the original function is equal to 1 or -1. Those points will also be on your reciprocal function. And look for local maxima on the original function will become local minima on the new function. Local minimum here becomes local maximum on the reciprocal. And the only other thing that I'm going to remind you of is that when you take the reciprocal of a number, you do not change its sign. So even though I knew I had a minimum here, I know it can't go below the x-intercept. All these positive values, when I take the reciprocal, still remain positive. So keep that in mind as you're graphing this question. Okay, that's it for this one.